Okay, so the third paper of this morning is Who Bears the Burden of Climate Inaction, and Catherine Wolfram is going to present.
Great. Thanks so much to all of you for sticking around. This paper is joint with Kim Klossing and Chris Knittel. And I think of it affectionately as our calculator paper. While we do some estimation of our own, a lot of what we do is draw estimates and elasticities from the literature and do multiplication. So not like super sophisticated methodologically. But based on our informal survey of colleagues, we are getting some answers through the multiplication that are different from people's expectations. So hopefully we are we're moving priors. What do we do? At a very high level, we are trying to assess how U.S. households are currently confronting and experiencing climate change. And we're trying to think about the distribution of the cost associated with climate change. So we can think about this, and the original title that we submitted was The Inequality of Inaction. Also, part of what we're doing is comparing a bunch of different vectors through which people are experiencing climate change. So I'll show you the numbers that we find in a second, but we're finding relatively significant burdens from climate inaction. And we do find that there's inequality, that lower income households and certain geographies that I'll highlight with some maps are disproportionately affected. And then I think somewhat surprisingly, and as I hope I'll convince you, counter to what the economic literature has focused on, we find that weather events and wildfires are far more important than heat and temperature. So here are the 10 vectors that we look at. I'll go through them. You don't have to focus on them too closely right now. I'll highlight the bottom row. So one thing to focus on is that we're going to give a range of estimates. We're calling them our more conservative and our less conservative estimates. Although for reasons that I'll get into, we think that they are both still conservative. We think there's still some things that we're omitting. But the less conservative estimates are that U.S. households are experiencing almost $600 in climate-related costs, and that almost 10% of the counties out there are experiencing costs in excess of $900 per household. So first I want to tell you about different inputs into the vectors. Okay, so here's the map of the estimated costs, and you can see that areas in California will hopefully convince you associated with wildfires are experiencing very high costs, as are areas in Colorado associated with higher insurance costs, and also Louisiana and Florida associated with the hurricanes and associated flooding there. Also, this is not yet in the papers. Thought it would be interesting to this crowd. We look at the burdens by counties that voted for Harris and counties that voted for Trump, and find that they're almost identical. If anything, the counties that voted for Trump are experiencing higher average costs associated with climate change. Okay, so there are different inputs that we're using into the vectors. One of the important inputs, or the ones that we all associate with climate change, is heat. On the left, this is a measure of cooling degree days. That's basically, how many days and how far above 65 degrees it is. What we're plotting here are changes between 1981 to 1990 and kind of the current period. On the right, we're plotting heating degree days. That's kind of how far below it is, below 65 degrees it is. And the key message here is that everything's red. Yes, it's gotten hotter. Almost universally, there's a little bit of blue in the heating degrees, meaning that people have more heating degrees, but in general, you're seeing a lot of temperature increase in the US here. The other important input is wildfire smoke. So relying on some work from Marshall Burke and co-authors, this is a plot of increases in particulate matter from wildfire smoke between 2006 to 2010 and the current period, 2020 to 2024. And again, you can see kind of the California areas, but also interesting some of the northern states in the US associated with Canadian wildfire smoke that's blowing into the US. Another important input is going to be the floods and hurricanes, storms. I don't have a map of that, but we have some depiction of that in the paper. So one of the important things to think about is how much of the observed change in wildfire smoke, in temperature, in storms can be attributed to climate change. As I said, we're going to take a less conservative approach and a more conservative approach. For temperature, the climate science suggests that basically all of the temperature increase is due to climate change. In fact, the climate models, the current climate models, kind of predict that the US should be warmer than it is now. So in our estimates, we're going to attribute all changes in temperature to climate change. For storms, we're going to use a range of either 6% to 1/3. The 6% is based on some insurance company modeling with a relatively conservative assumption there about reinsurance. And the 1/3 is based on historical evolution of storm and flood damages, and is also consistent with some of the scientific literature on attribution of current events in the US. For wildfires, we're going to look to the scientific literature there. We think it's about 50 to 80% of current PM 2.5 from wildfire is due to climate change. Some of the wildfires would have happened without climate change, but the estimates are that 50 to 80%. So method and data, as I said, we're going to use the current literature as a guide, pull estimates and elasticities from the current literature. And for all 10 of the vectors, we're going to have a different estimation approach. We're going to come up with the dollars per household, so that's going to allow for a holistic comparison, but it's not literally like an apples to apples comparison that we can do. And I'll explain when I go through some of the vectors what the methodologies are. So we do find that home insurance is the biggest item that people are experiencing now, that the average household is experiencing $250 of increased premiums associated with climate change. To derive this number, we rely on some very good work by Ben Keyes and Philip Mulder. They have 47 million observations from mortgage escrow accounts. They have information there on what people's insurance premiums are. They work with climate modelers at these insurance companies to get risk scores associated at a very granular level, associated with the different households. And then they econometrically associate those risk scores with the premiums. What we do is using the same climate model that they use to forecast out to 2050, we backcast and find what the risk scores would have been without climate change. And so that's where we come up with the 6% number. That suggests that about 6% of current insurance premiums are due to storms associated with climate change. We also, though, use our 1/3 estimate based on some of the other scientific literature. That's what we've plotted here. This is our less conservative estimate. And so, as I said, you can see that some of that is California. Some of that is wildfires, but we can't back out the wildfire part of the insurance, so we're kind of lowballing it and saying that only 1/3 of it is due to climate change. But then you can see that the coastal areas, again, experiencing big increases in insurance premiums. Okay, so probably our most sophisticated estimate is for this graph, and it comes up with, so the insurance number was $250. This graph, we came up with $10. So, a lot of work, but not as important a number. This is a measure of changes in energy use, and essentially what we're doing is taking a survey of energy use that also includes information on the heat that people are experiencing, the cold that they were experiencing, as well as their demographics. And then we use machine learning to kind of identify which demographics are best at predicting the energy expenditures, and the machine learning model picks out the temperature variables as well, and then use that to kind of project onto every census tract in the country what their energy expenditures would be, kind of with the climate-associated changes in temperature and without. And just what happens is that people are spending more on air conditioning, for sure. We have a graph or a map in the table in the paper that shows that, but they're also spending less on heating. And so on net, it's a $10 increase. So the economic literature in environmental economics is really focused on the relationship between heat and mortality. And so here we do our own estimation although we follow the literature and use a fourth order polynomial. This is the shape of the estimate that we get, and then again we shift the temperature distribution here and recover the associated mortality. You can see that people do die from it being cold, and so things getting warmer is going to give us fewer cold-related deaths, but also some more hot-related deaths. On net, we find kind of a -1 associated with this, so it's kind of balancing out. But just in general, the temperature-related mortality that we're seeing is swamped, is like 1/30th the size of the other mortality that we're seeing, which is the PM2.5. I'll show you that in a second. On the inequality front, we estimate for different demographic groups, and we find that blacks and lower income people are more sensitive to temperature, both at the cold end and at the hot end. So, are benefiting from the reduction in cold days, but suffering with the increase in hot days. Okay, particulate matter exposure is like our second biggest thing relative to where insurance is the first. And so here are the counties that are experiencing the most particulate matter exposure. What we're doing is translating that into mortality using a particulate matter to mortality elasticity from Tatiana's work, so very inspired discussant choice. We didn't predict that this was going to be or expect that this was going to be so important, but we're looking at elderly mortality, and then using a value of statistical life year, because mortality amongst the elderly is not associated with that many more life years or that many life years lost. So that's what we come up with there. And again, PM2.5 exposure is negatively correlated with income, and so when we translate that into mortalities, we see that the cost associated with mortality as a share of income is higher for the lower income deciles. Okay, so in the remaining 3 minutes, I'll tell you a bit about some of the categories that I didn't talk about. One thing we do is we take our estimates for home insurance and then scale them up, because presumably people's local dry cleaners, the supermarkets, et cetera, are experiencing higher insurance costs as well. So we scale those up. The energy costs I'm not going to talk about because that's on the price side, and I didn't talk about that. We also have estimates on costs borne by government, crop losses, again, from the literature, and then mortality costs associated with natural disasters. That's like just using NOAA's numbers on how many people die from floods and hurricanes. So there are many caveats here. I think there are a number of omissions. We go through some of them in section 5.2. One is that we're not thinking about non-mortality health costs. So there is definitely work that shows that PM2.5 from wildfires leads to increased emergency room visits. We're not measuring something like that. We're not measuring any adaptation costs other than the change in electricity for air conditioning. We are definitely undercounting some factors. There's literature that suggests that floods and hurricanes can lead to increased deaths like for years after the events, and we're just using NOAA's estimates that are right at the event. And some of our other estimates or some of our other caveats I'll skip for the purposes of time. What I want to highlight, though, is thinking about temperature-related costs versus non-temperature-related costs, because I think this is an important point vis-a-vis where the literature is. So in general, we're finding that the temperature-related costs, the energy costs increases, the crop losses, and the mortality costs are a small share. It's less than 1% of our total estimate of how American households are experiencing climate change. Compare that to the social cost of carbon estimates, where kind of temperature-related effects on health, energy, labor productivity, and agriculture are 99% of the estimate. So, it's a 2% versus a 99%. It's really flipped. I think it could be the case, and this is one of our caveats, that the US is different, and so ideally we would do studies like what we have done for other countries, and maybe we would see that temperature-related issues are more important in those other countries. But I think it's also worth considering that economists really like things that are very precisely estimated, and we have these nice temperature shocks that we can claim are exogenous, and people are looking at temperature shocks at a given county and looking at mortality there compared to mortality in counties that didn't have those temperature shocks. And so I think we need to, consider the fact that the literature has looked under the lamppost, and that we need to broaden what the discussion is about the climate-related impacts. That's not to say that there is no work on the wildfires and the storms. There's some very good work that we drew on, but the balance, I think, is reflected in the social cost of carbon estimates here. Okay, so just to conclude, I guess I'm out of time. I will leave these lessons up, but looking forward to the discussants' comments and the comments from the room. Thanks so much.
Our first discussant is Tatiana Deriogina.
Okay, thank you very much for inviting me to discuss. This was a really interesting paper to read. It's based on a really simple but very important idea, and actually I'm kind of surprised that nobody has written this paper before, because it's an important question to ask. So we've known about climate change for decades. We know we're living with some of the costs of climate change, but nobody has yet quantified those costs. We've been focused on projecting what will the costs be 20, 30, 50 years from now, but it's really worth asking, what has it cost us already, and how is this burden distributed? If you've ever been to a conference where somebody uses current data to estimate the relationship between, let's say, temperature and income, and then tries to project it into the future, you'll see how passionate people feel. Some people feel about, you shouldn't do that. Technology is going to change. Everything is going to change. I don't believe any of your numbers. So you would think that it would be easier to do kind of a backward-looking analysis and think about, well, what has it cost us already? The technology was what it was, et cetera, et cetera. But it's actually also very challenging because we need to think about, well, which observed changes are attributable to climate change. And I agree with the authors that with temperature, it's pretty easy. Like, there's no kind of confounding factor that we know about that would seriously make us think that the temperature changes we've observed are from anything other than climate change. For extreme events, that is a much harder question, because the damage that gets caused is not just a function of the physical attributes of whatever weather phenomenon we're thinking about, but also of the capital that is in place, of the income that's in place, et cetera, et cetera. And so that is really challenging. We also want to know how much adaptation has already occurred, because obviously if there's been significant adaptation, then looking at damage is not enough. You also need to know what damage would have been realized had we not invested in these adaptive technologies, or really you should know what has it cost, right? Maybe the damage is irrelevant if you understand how much we've spent on adaptation and you add that to the cost. So this paper is really ambitious in trying to do all of that. And because it is so ambitious, it's in some sense easy to critique, because it's essentially made up of many standalone papers, is the way I think about it. As Catherine said, the methodology is different for energy costs versus extreme event damage, and so on. And each component does require, fairly strong assumptions, but you sort of have to do that if you want to put all these costs together. At the same time, it's a hard paper to critique, because I think the authors do a really great job about being upfront about the assumptions that they make, and they present both more and less conservative estimates. And I think, they're not off by an order of magnitude, right? So there is a range, and I think it's probably close to the right range if I had to bet my kids', college tuition on it, since we're doing that today. Okay, so I'm going to focus on my comparative advantage, which is extreme weather events. Also, these are key components of the overall cost. Another key component is, of course, mortality costs from wildfire smoke, but that's based on a paper that I wrote with people, so there's nothing wrong with that methodology at all. Okay, and then within extreme weather events, it's really floods and hurricanes that are key drivers of damage. So by an order of magnitude, the total damage from floods and hurricanes exceeds other disasters. But especially when it comes to hurricanes, the damage is really unpredictable. So in 2005, Hurricane Katrina was a record-breaking storm, but partly it's because the levees in New Orleans failed. If they hadn't failed, it would have still caused damage, but it could have caused much less damage. On the other hand, there have been events where we've also gotten lucky. So Hurricane Ian, a couple of years ago, was projected to hit Tampa Bay head-on. Had it done that, it ended up kind of missing it by a little bit and hitting a slightly different area, devastating that, but not hitting a place with as much capital. If it had, we may have had another record-breaking storm. So what I'm going to do is use the same data that the authors do to calibrate their less conservative damage estimate. The data set is called SHELDAS, and just take state year observations because they're not individual events in there, but it's a pretty good proxy for like big events, bad year, good year, and so on, since natural extreme events that cause a lot of damage are fairly rare. And I'm gonna bootstrap from the 1960-1980 data, which is the baseline no climate change period, and also 2020-21, a little different from what the authors do because I have a slightly different version of the data, to just get a sense of how different the conclusions about damage trends could have been. So basically what the authors do is they take the average in inflation-adjusted per capita damage in 2020-21, or in their case, a bit later, compared to the baseline period, and use the difference as what's attributable to climate change. And this is the distribution that you get. Ignore the x-axis a little bit because I'm getting slightly different numbers than the authors are, and we're trying to reconcile exactly why that is. But I am pretty confident that in the amount of dispersion that you would get. So basically, you know, some of these have 2 Hurricane Katrinas in them, some of these have none. And I think this gives a good estimation of, you know, the uncertainty in terms of what could the outcome have been had we gotten more or less lucky, you know, under the same assumptions about climate change. The other thing that I do think the authors should do is control for real GDP growth. So this is real GDP growth per capita from 1960. And so that means that even absent climate change, we would expect damage from natural disasters to go up just because GDP per capita has been going up. And that's currently not in the author's adjustments. So I went ahead and did this with the SHELDAS data, basically calculating damage per dollar, which is on the right y-axis, and that is in red, and the trend, the SHELDAS trend that the authors use, the per capita damage, is in blue and on the left axis. And of course, the scales are different. The spikes, by the way, that you see are the hurricanes. So that underscores just how important they are in driving the overall damage trend. In the mid-1990s, which is not in the author's data, or they don't use it to fit the damage, that's Hurricane Andrew, then we have Hurricane Katrina, then we have Hurricane Harvey are the 3 big spikes. And so those kinds of events are, of course, really going to drive conclusions about evolution of per capita disaster damage. And the per capita adjustment maybe doesn't seem like it makes, the GDP per capita adjustment doesn't seem like it makes that much of a difference. But then when you do the same kind of simulation using damage per dollar of GDP, you get a much smaller implied increase in damage. There's still a lot of uncertainty, and I think that uncertainty is important to emphasize. Again, on one hand, maybe we want to know an exact number, and then you don't want to bootstrap things. But if we're thinking about this as being useful for the near future in terms of thinking about, well, what damage, what costs might households have to pay next year, then thinking about the uncertainty potentially becomes important. And you see that when you do adjust for GDP, you do get some scenarios where damage hasn't really increased meaningfully. Okay, so I have 3 minutes, and I'll make a couple more specific suggestions. So the insurance data that they use is really fantastic, but we also know that households in the US are underinsured. Even households that hold insurance coverage typically don't have enough to fully rebuild their home if it's completely destroyed. And so I think the one big piece that's could be added in that would add a non-trivial amount of cost is the Small Business Administration's disaster-related loans that you could get data on. There were about $28 billion in loans made between 2016 and 2025. They are also subsidized, so that could be a cost component to the federal government. But that probably is going to be pretty small, but the loans themselves are only available for uninsured damage, and so they're a complement to insurance costs. There's also work about on firefighting costs and just how much money, mainly the state of California, because that's where a lot of the wildfires are, has spent fighting fires. And that's actually a subsidy to insurance, right? Because if insurance companies know that the government is going to come and try to put out the fire, they charge you less for insurance and so on. But that's obviously a social cost, and it could be a non-trivial one. Another thing that's missing from the current cost that I think could be added in is the cost of flood insurance. So people with mortgages living in high flood risk areas are in theory required to hold flood insurance, but this provision is poorly enforced, and it's missing from the author's current data. But flood is a disaster that there's widespread agreement among climate scientists is going to substantially increase as a result of climate change, probably has already increased, as Catherine has alluded to, work in the scientific literature. And so I think that is really important to add in. The authors have told me that they might be able to get some first read data on that, but if not, at least I think adding in the flood damage specifically from Sheldus on top of the insurance costs would be helpful, especially because a lot of people who should have flood insurance don't have it. Maybe some of them are ending up taking out loans afterwards, but I suspect a lot of those losses are just going uncovered, so they wouldn't show up unless you add them in explicitly. And with that, I will hand it back to the organizer. Thank you.
And our second discussant is Wolfram Slenker.
Thank you again to the organizers for having me. Great conference. I want to sort of follow up on what Tatjana said and sort of discuss this project. It's a really nice, important work. I think people have often focused on individual sectors. What's really nice about this paper is they ask what's already happened. They don't look at what the predictions are for the future and sort of whether this actually varies between groups. It's a very ambitious paper because you bring in so many sectors together. Most people just write paper on one sector, and the nice thing is sort of to compare them. She didn't talk much, Catherine, on sort of what they do with the energy data, but since this is a county level mostly analysis, and since there's a lot of heterogeneity within counties, if you want to think about inequality, they do this vast exercise of trying to basically approximate a distribution of energy expenditures within a county. I think it's a very important paper. I think two things she's already basically emphasized is that there's already an effect of climate change. It also highlights those huge spatial spillovers. So, the smoke from Canada is hitting us in the Northeast and so forth. There's currently a huge debate at EPA whether we should use a national-only social cost of carbon, meaning only counting national costs and benefits, or the global one. And it's just another sort of argument for why those global perspective is really important for a project like that. I would like to push another angle, but I think this is a sort of an important contribution. The United States has sort of one of the lower acceptances of climate change. I'll show you a graph in a second. There's a really nice recent paper by Bordini et al., which basically looks at within congressional districts about which ones have warmed more and which ones have really warmed less, facing the same candidate. And so you see that their shift towards more pro-environmental policies is more for the people that have warmed more. And I come back to that in a second. So here's this paper by that just came out this spring. You see that the United States is among the countries that still believes in climate change, but it's on the lower end, and whether we should do something about it. There's also this continuing survey that Yale has on the perceptions of climate change. This is the answer to the question, how worried are you about global warming? And one thing you see here is sort of the coast worry a lot about, the interior worries less. It's not really just a red-blue sort of Democratic versus Republican. You see, for example, South Carolina has quite a bit of red. They worry about it. They face hurricanes. So I think a lot of it actually is not just political divide, also whether you have experienced it. I'm going to push on this in a bit more. Maybe this is the first law of discussants, but if the paper is good, the discussion just goes on and down rabbit holes. So allow me to sort of make 4 points that are maybe not really that relevant, but what I basically do in the rest of the time is I want to talk a bit about temperature, because Catherine focused a lot on temperature. It really depends a lot on what part of the temperature distribution you look on. That's sort of my first point. I want to talk a bit about the 3 sectors they found the biggest effects and sort of some of the modifications, and then potentially 2 other sectors which I think could be sizable. The second one is not as sizable, but it's beneficial, and then sort of something on how they pick the time periods. So the first one is temperature really is like, you saw the picture for cooling degree days and heating degree days that energy companies often use, but it really focuses on a deviation from your optimal average temperature, which is like, if you went to the hotel yesterday, the thermostat is set at like 65 degrees Fahrenheit, so this is sort of what we aim for. But as it turns out, the distribution of temperature changes is very different both across the US and across the different temperature percentiles. So to sort of capture this, I'm going to show you something. This is degree days. So cooling degree days and heating degree days is basically this. You look at how much temperatures exceed certain thresholds or fall below certain thresholds. You measure how much you're above for how long, and then you just add it up. So this is basically the graph that you've seen already from Catherine, just at a finer resolution. So this is basically cooling degree days above 65 degrees Fahrenheit. You see how it's gotten warmer in the south. Now, if I change the bound, and I don't do this for like 18 degrees Celsius or 65 degrees Fahrenheit, but I only look at the upper tail, the extreme temperature. And as you've seen for the mortality relationship that Catherine showed you, really what matters is the tails of the temperature distribution. This is basically what happened to degree days above 86 degrees Fahrenheit or 30 degrees Celsius. And there is this sort of weird oddity that the US is in, is that extreme temperature, especially in the Midwest, has actually gone down. It's only the US and India, and I'll come back to a global perspective in a second, but in a way, weather for the United States, if you think about what has happened over the last 40 years, weather for large parts of the United States has been good. So it's actually, we haven't really seen, especially sort of in the mid-region, a lot of climate change, as we've seen in many other parts of the world. So what is then the reason for this? Why does it, there's sort of competing hypotheses. I have a couple of colleagues at Harvard, Peter Hybers and several, who basically say it's a feedback from agriculture. The idea if we plant more densely, we have more transpiration by plants, and this transpiration cools the atmosphere. Think about sprinklers in a restaurant in Arizona. And there's other people, this is like the Journal of Climate, that sort of say not at all. It has something to do with summertime precipitation. So this is basically looking at temperature over the summer months. And so if you look at the Tmax on the top left here, it's just so apparent how it's this huge chunk in the middle of the US that just has not seen a climate trend. So California is very different. The whole West Coast has warmed a lot. You can also look at minimum temperature. The minimum actually has gone up. And that's actually good because we don't like the cold winters. So this is sort of this weird oddity in the US. We've gotten nothing of the bad heat in most of the central and eastern United States, but we've gotten rid of the cold. I mentioned before, this is now a global picture where you sort of see it's a different scale, so you can't compare it directly. Again, it's sort of the US has sort of this cooling. The other big one is India. There's also different debates, whether it's irrigation there as well, whether it's just a lot of pollution, because pollution actually cools things down if you have a lot of aerosols, or also a change in wind patterns. You see a lot of the heating in the Middle East, and as a result of them getting hotter, the winds might have changed. Anyway, but one of the things is sort of a bit of a pushback when you say temperature is definitely just given and has nothing to do. There's also land use change and human practice changes that could potentially impact the temperature. Finally, then, this is sort of the mirror image here, where you look at the change in below freezing, and you sort of see how everything in the Northeast has basically had milder winters, which I'm very appreciative of. But as a result, sort of, if you looked at if you remember the Yale graph on sort of climate one, which had this missing thing in the middle, the South has seen more heat, the North has seen less winter, sort of noticeably something different as well. The middle is the one where there hasn't been much of a change. Okay, let me go a little bit on the sector-specific one. The biggest one is hurricane and flooding. So this is actually from Solomon Young. This is his dissertation when he was a student at Columbia. And the US is just a huge outlier. This basically just plots the marginal sensitivity to hurricane damage as a function of your wealth. And as you expect, there's a downward slope. Richer countries are less susceptible. For example, you see Japan here on the right. Japan is rich, has almost no effect of hurricanes. Well, here's the US. The US is just rich and super susceptible. You saw, Tatiana showed you this. We had Hurricane Katrina, $140 billion damage. It's just really out of whack from many other countries. So what do other countries do? This is like Japan, as I just mentioned. They have this huge caverns under the city that can basically absorb floodwater. I was on sabbatical in Zurich 2 years ago, and I went over some bike rides, and I was wondering what the hell they're building. And so there was a river flood, and if you remember Catherine's plot, the one region that actually has a huge insurance increase is Vermont too, and it's mostly river flooding, because they had several river floods. So this is Lake Zurich here. Interestingly, I can't, do I have a pointer? No. Right at the lake is where Swiss Re's headquarters is, the reinsurance company. And so you see a side river coming in that basically causes flooding. And so what did they do, which is just really amazing? They just dug a huge tunnel from the valley into the lake. So whenever there's now a flood, they just channel all the water. They would have basically hit the city. Oops, I can't go back. They basically would have gone into the city, now basically goes into the lake. So you can basically do a lot of adaptation measures, and the US hasn't really done them. The only reason why I mention this, we talk about damages, and I'm not quibbling with the methodology they're doing, but a lot of those damages happen because the US invests much less in those adaptive measures than other countries. Okay, the second one is wildfire risk. So when I started out as an assistant professor, there was another person at UC San Diego. His name is Tony Westerling. He's written like 30 papers on wildfires. So people have basically predicted for a long time that wildfires will go up. The one thing I would like to say too is when you talk about temperature, where there's non-temperature effects, wildfires are in a way a temperature effect, because what happened is that we have less snowfall in the winter, we have therefore drying of the soil, and therefore the stuff just combusts. So it's smoke, it's from wildfires, but it also directly depends on temperature and rainfall patterns. I skip over this because of the time. So one thing that's sort of unique about air pollution is that you see there's been this trend break. So we've really cleaned up the atmosphere. So you see this downward trend across different regions in the US. And over the last couple of years, it's been picking up. And that's sort of the role of wildfire smoke. There's a companion paper that just came out in Nature last week by Q et al. They basically train a machine learning model to predict an increase in wildfire smoke. They also find a huge effect on mortality. And they're slightly higher than what you find. I think one modification is, so you use sort of the PM response from Tatiana. which is a very well identified PM response. The thing, though, about PM to remember is it's a catch-all phrase for small articles. So unlike carbon monoxide, which we regulate, which is just one particular chemical atom, PM is all kinds of small articles. There's now a lot of research that shows that the PM from wildfires is actually much more harmful than PM that we get from combustion in sort of other processes, because we regulate those processes to basically have the optimal amount of excitation, all this other stuff. While wildfires, we just burn people's TVs and other things, and it sort of all goes up in smoke. And therefore, it's much more damaging. So you most likely have a bit of a lower bound there. On the other hand, on the mortality effects, there's been several papers that basically documented that the relationship between mortality and heat has been going down over time, whether that's due to ACs, or there's a new paper here by Mullins and White thinking it's due to basically healthcare access and cooling centers. Most likely this thing is flattening. And there's a really nice new paper by Jeff Schrader that basically looks at the effect of temperature shocks on mortality and finds you find a null result if they're correctly forecasted, but finds really strong results if they're not correctly forecasted. So the idea is, if I know it's getting hot and I can adjust, then much less people die. Okay, so what are then the other two sectors, point 3, that I think that could be potentially large that are not included? The first one is housing prices. So Fairweather et al. Have this like RNRDR that's basically looking at an experiment they ran with Redfin, where they basically told half of the population what their flood risk score is. It's the First Street Foundation that you guys use as well. And one graph they do is they basically look at the share of the people in the market that have the information, and as the share of the people with the information goes up, of the high-risk property, the housing prices really goes down. So you have to make a lot of assumptions about linearly scaling this up, but the results are like humongous. It's like an $85,000 decline, so in terms of cost, this would potentially be a really large one. The reason is that it basically doesn't just look at past trends, but since home prices are forward-looking, it sort of incorporates all the discounted stream of future ones that we get. The second one, on sort of the positive note, Albury et al. Have this nice paper about how we value climate. And like anything, there's sort of an intermediate bliss point. You don't like the extremes. Now, since vast part of the US has seen not an increase in the extreme heat, but have seen a decrease in sort of the cold, you could think that this is actually one of the positive side effects of what the US has experienced, just in terms of amenity value. Okay. Oh, I'm out of time, but the only thing I basically want to conclude on then is you compare the recent 5 years to like 10 years before. You have to be a little bit cautious just when we sort of do those generalizations. The last 4 years have been a really strong La Nina effect. They have really strong effect in the US, for example, in terms of rainfall and so forth. So the question is how generalizable it is. But very nice paper again, and I really enjoyed reading it.
All right, let's open it up. Tristan.
Thanks. So this is a super interesting paper, just covering the heterogeneity. But I have to say my main reaction to it was that the level of these costs seems very low. So relative to household income, we're talking less than 1%, much less than any private action a household could take, like buying a more efficient air conditioner or electric car. Also less than frivolous expenditure, like I looked up on Perplexity, households spend $1,000 a year across all households on sports betting. So this seems to suggest that there's no hope to mobilize a political coalition to take action on climate change. I want to ask, do you think that's right? And then I also want to ask, or I want to propose a hypothesis, which is that there's another area of costs which are about pollution and particulate matter from autos and plants. Tim Besley has this great paper showing you can justify shutting down coal plants based on air quality improvements alone. And so does that mean that the climate movement, if it's actually relevant based on these costs, should emphasize pollution in addition to climate change? Thanks.
Larry?
So apologies if I missed this in the talk, but I was just curious how you think about the stock flow type imbalances here, because typically when I think about new technologies, the new technologies are a lot more efficient than the old technologies. And so if we're kind of measuring flow costs, then on the one hand, I make a big lumpy investment now to reduce my flow costs later. And kind of depending on where we put that investment, it seems like it might have a really big effect on what we think these numbers are. And likewise, just in places where you don't have air conditioning, but now you need air conditioning, that's a huge expense. And so just kind of how those factor into the calculations.
Mark?
Thanks. This is a really helpful paper. I think it makes estimating the effects of climate change a little more real. And climate change is one of the world's worst political issues in that the politicians think that benefits are uncertain and in a distant future, and the costs are up front, like a change in the price of gasoline or energy or something. And really what this paper does, I think, is begin to bring some of those costs up front so you can actually make some kind of comparison. I think the one thing that might be a little useful is to kind of project some of these out a little bit into the future so that you can say, here are the policy changes that you may want to be making going forward.
Neil Barotra?
It's a really nice paper. I wanted to underscore, I think, something that the discussants mentioned, correcting for both changes in home prices and then changes in the cost of, so not just for GDP, but changes in the cost of replacing structures. So structures, their price index has risen much faster than overall prices. And then the other thing is, I think it would be nice to compare your estimates to what to sort of the damage estimates that you get from the recent set of papers that have tried to estimate climate damages. So like Pete Kleinow's paper with Ishan and Bilal Kanzik, they all have estimates of, given the amount of warming that we've seen, what is the cost in terms of US GDP? And you have sort of a bottoms-up comparison that would be helpful to see there.
Samantha Gross?
Thanks. I would like to emphasize a point that I saw Wolfram mention in his discussion, and that is the U.S. as an outlier in the hurricane and flood damage compared to our position with respect to GDP. And that really reflects a policy choice. We here in the U.S. have decided that we would rather pay to recover from disasters than to mitigate them. And that has likely led to higher mitigation costs today. And so one of the things I agree with others who have really appreciated that the fact that the paper focuses on current costs. But I'd also would really like to see a little more emphasis on the fact that these current costs reflect current and past policy choices, particularly with respect to the kinds of natural disasters that are driving the cost overall.
Christy?
Again, like everyone, I found this paper incredibly useful and really eye-opening. I just had two thoughts about using the homeowner's insurance premium as a way of getting at some of these damages. So and the two comments go in opposite directions. So my sense is on that there's been, over the period you look at, insurers kind of woke up and said, holy hell, we've been underestimating things. So I just wonder, our risks. So I'm wondering if that might make you overstate what the costs are going to be, at least if you try to go forward. But the other was, anyone who's lived in California knows quantity rationing in insurance is a big deal. And so that could be something that says, in fact, it's much higher than your numbers suggest.
Tarek?
Sorry, do I understand correctly that if we now kind of estimated instead on like changes in house prices in Tampa Bay, like we would get much higher numbers? Like, so, sorry?
Can you say that again?
Do I understand correctly that if we kind of calculated the cost based on the observed changes in house prices in Tampa Bay, like that they went down like 5%, massively valuable capital stock, it seems to me that you would get much bigger numbers than the ones that you've calculated.
If you're...
I mean, I think one response is going to be that is potentially just capitalizing the insurance cost that we are measuring, that we already have that because we have the insurance cost.
Adele?
Thanks. I really like this work, and I congratulate the authors on what I think is a really important contribution. In part, it's not just these average costs, but it's the distributional aspect in the discussion, because so much of the discussion around climate policy is around the distributional outcomes. And so I think getting at the climate costs in those same terms can really help the policy discussion. And so I would encourage the authors to also build out the discussion around socioeconomic distributional aspects as well as the regional, and I know you guys are thinking about that. But I also want to emphasize there are a lot of ways in which you're conservative that you didn't mention. So for example, we talked about insurance capitalization, but insurance only covers structures. So if your land becomes uninhabitable, that is not covered in the insurance dimension of those costs. You're not talking about costs to the U.S. from climate damages abroad, which could be significant through prices of traded goods or geopolitical risk and conflict. And there's whole channels of damages that aren't in here. And just to name a few, ocean acidification, vector-borne disease, ecosystem services in its full range. And then again, like others have said, avoided damages are rising on the margin, or we think they would be. So these are the costs we're never going to get rid of, without maybe extensive adaptation, or maybe even then. So thinking in terms of how do you frame this to inform like that incremental policy for emissions abatement would be really helpful. But great work.
Elaine?
So fascinating paper and great discussions. In looking at costs that come from insurance and recovering from hurricanes and also extreme rain events, I wonder whether changes in the way we urbanized and built our cities, though, may be driving things up. And let me give a couple different examples here. So one, so my husband's a Louisianian, right? So Louisiana had two giant hurricanes, Hurricane Camille in, I believe, 1968, Hurricane Katrina in 2005. I think it's reasonable to say that Louisiana had become less rural, more urban, and so there would be more people in New Orleans and region to have been hit this, so the real estate's going to be different. The density, if a hurricane hits any given geography, it's going to hit more houses and arguably more that cost more. Similarly, if you think about, is it Ian that hit Houston? No, but the big hurricane that Harvey that hit Houston, right? Houston is the epitome of urban sprawl. It has grown extremely rapidly, and one of the factors in the degree of the damage is the extent to which it has become paved. So there is not natural drainage. And do we have are we overestimating? For all the things you may be underestimating, are there some things that it's becoming more costly, not because the storms are more severe, but because our environment is actually less resilient to it?
Steve?
Thanks. I want to make first something explicit, which I think is implicit in many of the comments, which is if we take the numbers in this paper at face value, and it tells us very little, almost nothing about what the appropriate policy response should be. There are various ways to mitigate or adapt that would reduce the policy costs. My understanding is that forest management practices, for example, greatly influence the frequency, scale, and costs of wildfires. Building in flood zones and low-lying coastal areas obviously has a huge impact on the effects of hurricanes and floods. And even if you get to the decision you want to abate carbon emissions, well, then there's a whole set of questions around, well, to what extent do you want to do that through regulation versus prices? There's carbon capture. Do you want to focus on geoengineering technologies that might help us head off the very worst possible outcomes if they were to emerge suddenly? So I just want to make that point. Secondly, I want to pick up on something that was hinted at earlier. when I look back at the history of U.S. environmental policy, I look back to the 1970s and the Clean Air Act and Clean Water Act. These seem to me to have been quite successful politically and in terms of their outcomes. And one reason is because I think the benefits were very tangible and concrete to people. So I think somebody made the point about the coal-burning power plants. Okay, well they're huge local and regional benefits to either shutting coal-burning power plants or greatly controlling their emissions so that they don't have such harmful effects. I think, go back to forest management practices again. Regardless of whether you think the globe is going to increase temperatures a lot or a little in the coming decades, it seems self-evident that our forest management practices are deficient. Those are things people understand very well. So I just want to question the whole political viability of the strategy that's been used to deal with carbon warming. And I think carving it off into pieces of smaller, more concrete environmental problems that are often related to global warming in some way, but have particular local manifestations, it's maybe easier to build political coalitions to address those problems, especially as I learned from in this paper that the United States is somewhat on the favorable end of the spectrum with respect to the direct fallouts of global warming. So maybe it's not so surprising that the U.S. is an outlier, at least among rich countries, in the modest levels of support to respond to global warming.
David?
First of all, I agree with everyone. That's a really nice paper. I really learned a lot. I want to pick up on both what the authors and Adele said about all the things that aren't here, and then the comments from Wolfram in the discussion, also Tarak, about house prices. So I think for relatively narrowly confined things, wildfires and flood damage, it seemed to be possible to look at house prices with some kind of, matching differences in areas not exposed, and try to get a different way of going about it. And then you could compare it. Is this just roughly equal to some reasonable capitalized insurance costs plus mortality things, or is it way bigger? And I think sort of implicit in some of what you were saying at the end, and some of what Adele was saying as well, is there are a lot of things that are left out, and you were very clear about that. But in the case of wildfires, there's uninsured losses, including the risk to your family heirlooms. You can never, or if the land becomes uninhabitable. Non-mortality, health costs. It's stressful to live in an area. If I know my house might burn down, I might choose to just not live in the area, even if it was fully insured. That would affect house values. And also expected future. If I live there, I'm going to have to invest in various adaptation things that would not show up at all in your estimate. So if you were, within, I think you shouldn't be aiming to show, oh, yes, this matches what we'd expect. The question is, how far off is it? Is it 50% too low? Is it a factor of 3 too low? And I think that would be extraordinarily, I think that would be very informative.
Just one follow-up comment. The evolution of this paper has been really interesting over time. The first draft that we got was around the time Los Angeles was burning. And then that was the initial proposal. And then the first draft over the summer was when Texas was flooding. And so as results evolved, I kept looking, and there's a discussion about the importance of disasters, and especially these very localized disasters. And so I kept looking in the results for big impacts of these disaster events. But sort of by their nature, they're very localized. And initially I was looking for flooding effects, which are very localized. And so I wonder, this is sort of to Steve's point, whether we have the metrics that capture, are we looking at the impacts on a sufficiently localized and focused level that we can capture the impact? Or like if you looked at the average impact over a state, we wouldn't see very much, right? So are we mapping the disaster location to the impact in a way that really captures what seems like the magnitude, but doesn't really show up in the numbers?
Okay, so let's let the authors respond.
So thanks to Catherine for doing such a great job summarizing our work, and thanks for the discussants who all along I think have really improved the paper and continue to do so. It's really useful. The very beginning of this paper started with a frustration that I think Catherine and I and Chris shared, which is when we think about the climate policy action problem. A lot of what stymies good policy responses is people will say, oh, you can't carbon price because it'll hurt poor people because they pay more than rich people do as a share of their income on things like energy. And one solution to that is, of course, dividend back the carbon price, right? But another key part of the motivation for this paper was to say, well, not doing something is expensive too, and it's expensive even if you ignore the rest of the world and the global externality, because as Mark Mazur points out, that global collective action problem is part of what's so vexing here. But what's really astonishing, I think, is the fact that even if you focus on U.S. costs, we're conceivably already at the point where our costs from inaction exceed the cost of action. So if you compare the work that's in this paper with work that Catherine and I and Neil and others have done on policy, or with work that Chris has done on policy, the cost to a household of a carbon price on their annual energy bill is in the neighborhood of $200 to $500, depending on how aggressive you are with the carbon price. And this is comparable to the current costs already. So I think that's a really useful thing to sort of think about in terms of framing this paper. And it gets in part to Tristan's point about how do we use this information to build climate policy. I think one is to recognize that some of these factors are small, but we've omitted a ton of things, and I think it's useful, as many suggested, to sort of try to put an envelope around that. To note that the future is probably going to be very different from the present, because climate change comes with a lot of tipping points, and to sort of think about how to relate that to some of the other estimates. And I thought Neil's idea of relating this to the GDP estimates and doing kind of bottom-up versus top-down is extremely useful thing that we could include in the revision. So I note that a lot of people had suggestions for things that we could add, and I think Steve's emphasis on micro responses is also a good policy tool to think about, what are the specific implications for forest management and things that might be much smaller than carbon pricing versus regulation, I think is a really useful feature of this. And just to end with Jan's point, I think that one of the inequalities that we point to, and there really are astonishing sort of decile graphs, and we didn't have time to show all of them, but almost any cost is really borne disproportionately by the poor and disproportionately by certain regions of the country. But there's a really hyper-localized cost too, which is, you can imagine if you're a poor person in a rural county in California where the fire is, right, that's an extraordinary cost for you compared to being the median household, right? So another thing to think about is how do we as a society build social insurance for those kinds of really difficult things.
Yeah, let me second the thanks to the discussants for sure, for both these comments and comments throughout the process, and to the group. A couple specific points. We know that there is non-coverage from insurance and that we're missing that currently. We are trying to get data on kind of value at risk, and so hopefully we'll have that for the final paper. I really like that Wolfram put up the findings that U.S. households are different from many of our peers and other developed countries, that we don't seem to agree that climate change is as big an issue. So part of what, at least I think we're trying to do with this paper is change the conversation from being about temperature, because as you showed, it seems like the people that aren't experiencing big temperature changes are the ones that don't believe it, but just say, look, there are other things that are related to climate change, and those are probably the most important things for U.S. households. I guess any comment about temperature, I'm just going to say, stipulate that we're off by a factor of 2, and that makes our -1 a -0.5. So I don't know. I just think the conversation should be about other things besides temperature. I agree that wildfires are related to temperature, but they're not related to temperature in the way that the most of the literature has kind of measured temperatures. They've measured very, very local shocks to temperature. I completely agree on the insurance capitalization not being everything. I mean, I meant to say that we're getting, like, we're not completely ignoring it, but I agree that there are a lot of things that aren't reflected.
Do we want to, is Chris on? I don't know if Chris is online and if he wants to say something.
I'm online, but you guys did great.
The voice of God.
Thanks, Chris.
Did Chris want to make any other comments?
I don't think so.
I think he's good.
All right. Well, let's give the authors and discussions a round of applause.